We all have heard of Newton's apple story where he was sitting in his garden under an apple tree and was suddenly hit in the head by a falling apple. According to the legend, this is the moment that Newton supposedly discovered gravity. But have you ever wondered why the apple falls off the tree in the first place? To understand this, it is important to start by looking at the force diagrams for the apple and the stem. The apple has two forces acting on it. The force exerted on the apple by the stem and the weight force of the apple. The stem, on the other hand, has three forces acting on it. The force that the tree branch exerts on the stem, the force exerted on the stem by the apple, and the weight force of the stem, which we will ignore in this case since it is very small. The stem of the apple is elastic, meaning it stretches due to the increasing force of the apple on the stem as the weight force of the apple increases. Since the system is not moving, this means the force of the tree branch on the stem also increases equally with the force of the apple on the stem. Meanwhile, there is a force acting on the stem known as the restoring force, which solely intends to pull the stem back to equilibrium. From there, two types of material must be understood: pliant materials and rigid materials. Rigid materials undergo small deformations under the influence of large forces. Pliant materials are the exact opposite. They undergo large deformations when subject to small forces. Since the stem experiences very small changes in dimension of width and length while being stretched, it would be considered a rigid material, as opposed to a pliant. From these conclusions of a restorative force on the stem being an elastic material, it can be further interpreted as the stem of the apple basically acts as a spring. Mathematical components can be calculated with the formula: restoring force of the stem F sub SPY equals negative K parentheses delta Y and parentheses, where F sub SP is the restoring force of the stem. Y denotes that in this case the apple's forces are acting according to the Y component. K is the spring constant with a negative sign to denote that the force and direction of displacement point in opposite directions. Delta Y acts as the displacement of the apple due to the stem's elasticity. As the weight of the apple increases, due to the mass of the apple increasing as it grows, the stress in the stem, known as the tensile stress, also increases via direct proportionality. The ultimate or largest amount of physical stress that the material, in this case the stem, can undertake before breaking is known as tensile strength. It is defined by the equation tensile strength equals the maximum force divided by the cross-sectional area of the stem. In this case, we can calculate the tensile strength by first finding the maximum mass that the apple can be before breaking the stem using the equation maximum mass equals the maximum force divided by the gravitational acceleration constant. In this case, we can use the average mass of an apple, 0.1 kilograms, and multiply it by the Earth's gravitational acceleration constant, 9.8 meters per second squared. To get the maximum force, 0.98 newtons, we can take this calculated value for the maximum force, 0.98 newtons, and divide it by the cross-sectional area of the stem, which is 7.9 times 10 to the negative 7 meters squared. When we let the radius of the stem be 0.5 millimeters, the solution for tensile strength will be about 1.2 times 10 to the 6th newtons per meter squared.